Okay, second part of this session today. So now we will talk about another topic. Of course, very interesting topics as generally. Monitoring maintenance standards, work as imagined works, and work at a drone, what's your gap and how do you know? Chris Drew from Bain Simons and Tim Rolfe from the Bristol Group.
Thank you, Jean-Marc, and good morning, everybody. My name is Tim Rolfe. As Jean-Marc said, I'm Director of Safety Standards at Bristol Group. My background is as a pilot, in fact, and training, and some of that background, which allows me to understand the windmill bit that Francisco was talking about earlier on, is what I hope is leading into the discussion we'll have over the next 20 minutes or so. Chris, would you like to introduce?
Thank you. Morning, everyone. My name is Chris Drew from Bain Simons. I'm going to co-present this session with Tim. I'm an aircraft engineer by background. I'm just here to press the buttons for Tim to advance the slides, so that's why I'm here. No, we're going to have different slides to talk about, and Tim's going to start us off. Thanks very much.
Thanks, Chris. It is the ultimate in automation, of course, if you can have this happen. So, we'd just like to put this in the context of the evolution of safety and where we find ourselves today. We're going to talk to you about a program which existed in Bristol about 10 years ago. It was all driven towards monitoring maintenance standards in the company with the perspective of trying to improve safety. It didn't land well for a number of reasons. And sometime later, we've looked at rejuvenating the program and understanding maybe why it didn't work so well. And hopefully we've got to a product which we think works really quite well. We'd like to share that with you and certainly get your feedback. But if we look at the evolution of safety over the decades, we started off with a very compliance-based sort of process, the idea that regulation is going to underpin everything, and as long as we're following the regulation, we're checked against following the regulation, all will be well. We then added the notion of quality, which is split into two parts. There's the quality control, so you're looking at production quality at the shop floor, and then an oversight through a quality assurance process. Around about the 70s, we started talking about human factors, which arguably made things better, and in some cases just added a bit of complexity, which I think some of us are still wrestling with. And now, of course, we're in the era of safety management, where there's regulation around having a safety management system and putting a framework, which isn't as well described as I think, or prescribed as it might be. And it still requires operators to understand exactly how they apply what they do in the safety environment. And now, of course, we're talking about performance-based safety and performance-based assessment. So that's the focus right now. And what's interesting about this sort of progression is that we shouldn't say that these are all mutually exclusive. There are elements of each of these sort of perspectives which are really important. And I think one negative of this is that as you transition through from compliance quality and then safety management, there's perhaps been a notion that we can rely on others to come in externally and tell us how we're doing. Whereas now that we're back in the performance-based environment, there's perhaps more of a focus on us as operators to define what are our objectives, what are our targets, how will we measure our own performance against them and demonstrate to others how well we're doing. So it's in that context that we'd like to talk through our process of maintenance monitoring. Chris.
Thanks, Tim. Yeah, so this is Tim's house. He's obviously a pilot, has lots of money. You can see what might have happened to this house here. It's got lovely chandeliers, it's got lovely carpets inside it. But obviously the foundations of this house aren't maybe as strong as they should have been. And I think going back to the slide that Tim just showed with the spotlight on performance-based environment, performance-based regulations, and EASA obviously in its guidance material around this topic emphasises that keeping a focus on good compliance, good quality management or compliance monitoring is as important as anything else in order to give us the balance we need to create a safe outcome. Some of the discussions that were on the previous panel session were alluding to this, that we need to think about the human in the system, we need to think about how we set up people to succeed. And a great presentation this morning about human factors. And actually, you know, the human condition is something we can't change that easily. We can change the conditions within which people work. And that's a balance that we're trying to strike. And the program that Bristow is running, this maintenance process and procedures monitoring, is trying to evoke this performance in the workplace. Ultimately, it's about finding out what people actually do day to day to get the job done. Some of you will have heard of Professor Eric Hognagel's Pt.2 process or concept. Has anyone heard of that one? Yep, thank you. So basically, we're trying to see why things go right as well as why things go wrong, and what the gap is between work as imagined and work as done. Some of you will have seen this slide before if you've seen Professor Hognagel's work. It's really looking at the maintenance design process right through from the certification of the aircraft through to the writing of the maintenance manuals and procedures, work done in the camo to set up the maintenance program. And of course, this is all in a perfect world to be done on the aircraft in reality by human beings at night with time pressure, in the cold, with insufficient tooling, time pressure, etc. It's all classic human factors stuff. So the question is, for an operator like Bristol Helicopters, how can they minimize surprises in their operation? How can they make the maintenance process reliable, repeatable, efficient, and actually, how do we do that through our SMS? How do we prove that we are doing what we say we do? This is a complicated, busy slide, but not one you're supposed to we'll go through step by step. This is trying to go back to another point that was made this morning about the competencies of nominated post holders. Where does the ownership of compliance lie? Where does the ownership of safety lie? How do we understand the competencies of Form 4 holders who actually own compliance and own safety? And how does MPPM fit in? Actually, if you look at the green management system here at the bottom, this is about the insurance of compliance, right from the compliance framework through to how we set up our organisation. And then we're looking at process controls and system controls and how we measure and report those to our stakeholders at the top. And MPPM, this process that Tim's going to describe shortly, sits right in the heart of good compliance. If you think about why regulations are written, they're written from bad experience and blood and accidents, and we are defending ourselves against future accidents by being really good at compliance. So if we know that we've got good system controls here, and we know we've got measurement and reporting of these system controls to the wider system in terms of compliance monitoring and ultimately to the accountable manager, then MPPM is trying to really give us a really good focus on what people actually do to get the job done day to day. So that's a safety 2 angle on it. So it's bridging the gap. MPPM is the acronym, Maintenance Process and Practice Monitoring. So if you know what a management system is trying to achieve, and in this case it's a maintenance management system, you know the intent behind it, you know why in the year 2000 we started to write human factors elements into the Part 145 regulation, then that's the maintenance process. It's a socio-technical undertaking, as was said this morning. It's humans in a system. So in our complex world of complexity in terms of technology, of helicopters, of organisational context, of commercial contexts, how does the maintenance process survive all that in terms of being reliable and repeatable? You go into a classroom, we get trained. When you come out of the classroom, you go into the force field that is the hangar door, and then you're into the culture. You're into the normative behaviours that people have day to day. So if that is acknowledged by us all, because we see it in accident reports and incident reports, then how do we monitor those practices in reality? How do we really get a good confidence that people are doing what we think they're doing day to day? So MPPM is a little bit like a LOSA type approach to monitoring what goes on day to day, to monitor work behaviours during normal operations. That's the important bit. It's done peer-to-peer to discover procedural and systemic threats and errors. Practical drift in ICAO terms, as some of you recognise as well. It's about being data-driven as well, generating a baseline for our data, implementing changes from trends collected from the MPPM process, and then following up and showing people that this is good for you, actually, as an individual. It's good for our business, it's good for safety. Maintaining engineering competences and standards, which Tim will talk about shortly. And it is about the human in the system, as I said before, where we look at putting competent staff on top of our maintenance systems, then the workplace has a great deal to do with the way people behave, the way we resource things, the way we train people, the way we lead and have our culture processes set up for improvement. So it's looking at the maintenance system. It's not designed to look at individuals and point to them and say, you're doing this wrong, you're doing this right. It's really looking at the systemic improvements to the maintenance system. That's where MPPM comes in. So over to Tim to show a bit more detail about how that is built up.
Thanks, Chris. There's a lot of detail on these slides, and you don't need to know it, but it just provides a bit of a framework, and I think they're readable once you get the slides, and I believe everybody will have that on a stick. But to Chris's point, how do we then go in and understand what's happening in the workplace, and who should be the people to do that observation? Traditionally, in the past, if you were to look at the workplace assessment, we would do that through perhaps an HSE audit or some quality audit that comes in. So somebody from outside of the working environment comes in and judges what the state of the workplace is, whether the facilities and things are in place appropriately. And probably has a look at, to some extent, about practices, but they might not be qualified in the role. And who's actually looking at the competencies of the individual? My argument is that unlike pilot training, where we have a periodic review every 6 months at least, somebody comes in and sits down and looks at your competence, depending how they measure it, is differing as the regulatory environment changes. But there's no such process formalised for engineering, and there absolutely should be and can be. So the MPPM system has a scoring tool which allows us to start collecting score-based data, because it will allow us to benchmark and baseline where we're starting from. And it will also be broken down into areas which we'll show on the next couple of slides, which will show us where we're strong and where we're weak. A really important factor of this is identifying strengths within your system as opposed to just identifying weaknesses. I think one of the challenges of all safety initiatives is they tend to be quite negative and tell you you're failing at doing stuff and you're not doing it as well as you might do. So this will give you the opportunity to capitalize on your strengths, but also focus on where you're going to make efforts and your weaknesses. So the scoring system has a system of 5 levels of output, one of which is unacceptable and you can't carry on, you've got to do something, and the rest are all giving you something to build on and improve on. But split into 2 sections. So you see the columns work environment. So part of the observation is looking at the working environment. There'll be more detail on that in a second. And then there's a competency review of the individual and how they're performing their task. Thanks, Chris. So looking at the work environment, we're covering areas now which traditionally have been covered by perhaps health and safety, so facilities, equipment and tooling. And I think this is the bit that we struggle with, is how do the guys who are trying to do their job get hold of their information? How easy is it to get hold of procedures? How up to date are those procedures? How are procedures and tasks planned and overseen? What is the complexity of a given task? At any point, is anybody sitting down and judging a task and saying, do you know what? This is a good deal harder than we thought it was to do this task in this particular environment. So we need to take that into account. And we also look at, are there any extenuating organisational factors influencing what's happening in this particular workplace? So that's one half, looking at the work environment. The next half is looking at the actual competencies of the individual employee, so the individual engineer. And to those of you who've been listening and didn't switch off when Eric gave us all permission to do so in the earlier presentation, these are very similar competency sets to the competencies that have been used in the pilot framework defined by ICAO. And why not? These are non-technical competencies as they've been described, and why don't they apply to the maintenance environment, to the engineering workforce? What you see here is 5 sets of competencies, and within each of those competencies are some descriptions of behaviour, positive behaviours. This is the underpinning of what we're doing in the EBT system. If an engineer, in this case, did all of these things well, and he displayed all of these behaviours in situational awareness, communication, team working, problem solving and decision making, he'd be brilliant. We accept that people don't do all of these all of the time, but we get people, or give people the ability to recognise where they are doing things well and where there's an opportunity for improvement. These are the non-technical skills. On the flip side of this is description of technical skills. And this again is complementary to what we saw in EBT. Complementary set of technical skills. Knowledge in the top left-hand corner, controversial, again, whether that's a skill or not, but it's in there. We need our people to display that they've got appropriate levels of knowledge for the task. And then top right-hand side, the application of that knowledge and application of the procedures which they work at, or they're required to work to, are being followed. The bottom 3 sets there are novel, and they're novel to both the maintenance concept and to Bristow. And that was important. You can't tell people this is what good behaviour should look like. You have to get people enrolled into them understanding what it looks like. We went through a process with our engineers of asking them to accept whether the non-technical skills and the knowledge and the application of knowledge and procedures were acceptable. And they made a couple of changes. And then we had some obvious technical skills which we had to take out from the pilot skill set. needed backfilling, and this is what our guys came up with. Key areas around technical skills themselves, the hands-on spanner turning, oversight of themselves and those that they're working with, and some behaviours associated with that. And then lastly, and what came out and surprised me was quite linked to our use of automation, but the maintenance use of technology. How do they tap into all of the technical systems that they have to go to support their work? So again, if everything that was done here is done really well, you've got a really good performing individual in the business. I think if we're going to come back to the notion of culture, which Miguel was talking about earlier on, if you want to instill a culture in a business, you have to be really clear about what you believe in as an organisation. You can give these to people. Our guys have these in the form of a card, which they can keep about the person. They'll use them certainly as part of the observation, but these also appear as posters on the wall, and that's a really important part of culture. If you can display to people what the organisation believes in as good behaviour, that's a real driver for changing the culture. So in terms of the observation, you may be getting a sense it's a little bit of a blend of what we've seen in the pilot community, a bit of a blend of what you might see under a LOSA type observation, somebody coming in and looking at your work. And there are some attributes which are similar to LOSA. The observations that are done in the workplace are non-punitive, they're de-identified. And that's really important because you want to get the person that you're observing doing the work as they would be doing on a daily basis, not putting on a great performance just because there's somebody in here to judge them and see what they're going. You have to have a systematic process of observations to build up this data. And what has happened in the past was MPPM observations were done by the quality department, so somebody's coming in from outside, you get best behaviour, and nobody really sees any value and understands, because nobody was really seeing any output. It never really led to any targeted enhancements, provided everything was going well, okay, that was fine. But this is being done with trained observers who are trusted, they're SMEs within their own business, they know what they're doing. We're reconnecting the supervisor and the guy on the shop floor, the guy he's tasking. So the supervisor's got an opportunity to mentor whilst he's doing this, to talk and see for real what the guys that he's tasking to do, what they're actually doing. All the data that we collect from this is private. We give people the opportunity to volunteer in and volunteer out. We are in the early stages of this. I can't pretend we've got a huge amount of data, but I will tell you that we haven't had anybody turn around and say, I don't want to be part of this yet. And we've had the ability, certainly, to focus in on where our weaknesses are and say, right, this is going to be the target for our continuous improvement over the course of next year. And we've started to see some real positives. But these characteristics, I think, are a blend of what you might see in a LOSA. It's not a LOSA. What we tried to set out to do with the original MPPM concept, and then what we've brought over from a sort of competency-based training aspect from the pilot workforce.
Thank you. I think, conscious of time, we've got some more slides, but I think we can probably take some questions at the end. But just to summarise, really, this is a change. It's a change process. We have to set this up correctly in the organisation to make sure people are bought into it, that leaders want it to happen, that understand the processes that are going on, and to expect different behaviours on the shop floor. You talk about safety culture and what that is comprised of, including flexible and questioning cultures. This will start to create those things, and that behaviour needs to be expected in the workplace, and management need to be able to accept and make that an okay thing to do. So there's many more things around these points here we could talk about all day, but we won't. We'll finish there, and thank you very much for your attention.
Please, have a seat. Thank you very much, Chris and Tim. Just a feeling, a personal feeling means you need the task force, knowledge about this, but you need also to share with them and to get some agreement to work on that, because it is typically a channel at the end, and you must be from the beginning to the end all in agreement. So it is a key point for MPPM for me, what I understood, by the way. Thank you very much. Next presentation. Good morning, Mr. Gattino.
Good morning.
You will present something regarding the EVS. You probably already know what the EVS is. the proposal is to have an enhanced systems regarding the EVS. So please, François,
Okay.
have a talk.
Good morning, everybody. Yesterday, in his opening speech, Mr. Key put emphasis on safety. And what I'm going to present to you today, it's a safety system. 3 years ago, in this room, I had presented the EVS 1500. The EVS 1500 is not in production anymore, and it has been replaced now by two models, EVS 1400 and 2300. The 1400 has been designed for, let's say, general aviation and helicopters, single-engine helicopters. It has been designed to be economical, and although it is economical, it has a high resolution. That was not the case of the 1500 I presented 3 years ago. And on the 1400, you have a possibility of 3 different field of view. You have to select your field of view before ordering the EVS, you see. And so you have 45 degrees, 69, and 90 degrees. Most people are selecting the 69 degrees. Now, the EVS 2300 is a much more advanced sensor. It has, of course, an infrared sensor in it, but it has also a color camera, and the two images are blended in order to give a much better resolution compared with the whole system. And because you have these two cameras, we have a dual output, which means that if necessary, the infrared image can be sent on one MFD, and the color image can be sent to another MFD if necessary. And the 2300 also has a software to make it compatible with synthetic vision, you see. So this is why now we are talking of combined vision system. Why do you need an EVS? You know better than me what are CFIT, IMC, so we have discussed that yesterday, and this is where the EVS can help, you see. This morning we had the case of a helicopter going into IMC with an EVS. Maybe it would have avoided the IMC condition, and with an EVS, maybe it would have escaped more rapidly and safely, with more safety from the IMC situation. The EVS is also good on offshore to avoid the round deck landing, you see, because on the screen, the co-pilot could have, of course, the image of the platform where the helicopter is approaching. This is everything you can expect from an EVS, and we have a very simple rule. You see, we consider that on the screen you will obtain more or less 10 times the distance compared with your naked eye. This is the typical infrared image, black and white image. And by the way, on the 2300, we have the possibility to change the polarity, black and white, if necessary. This is London in a foggy morning, and this is just to remind you that the EVS works, of course, during daylight operation, and the EVS, for those who are flying with NVGs, could be a good complement to NVGs. Usually, we work with a 5 degrees look-down angle. For each type of helicopter, that angle, of course, has to be calculated, but generally, it's around 5 degrees. And we consider that generally, we obtain on the screen a visibility which is more or less 10 times the height above the ground. This is the EASA, this is the STC we have for the EC135. We cover every model on the 135. This is the installation on the 135. Installation now on a 109. Installation on a Bell 429. Of course, we need a display. So here it's a Thales display from the 135. Here it's a SEGEM, very modern MFD. On the right, it's quite interesting. You see the screen has been divided by two. On the upper side, you have our image, and on the lower side, you have the mapping. Yeah? This is also a new generation of MFD. Here it is the Rogerson MFD with NVG compatible panel. And if you are flying on an old helicopter, then we need to have a dedicated screen. Here this is a flip-flop display inside of a fixed wing. This is just to remind you that we deliver quite a lot of sensors to the fixed wing world. Here on this CL415, you have the EVS mounted on the roof. And this is a small video. I assume that not many people in this room are involved in firebombing, but I just show you that because it will show you how the EVS can penetrate in any kind of limited visibility. In the left-hand corner, we see the smoke and only the smoke, and you can see on the EVS screen, we see, of course, perfectly the fire, but we have no smoke, you see. And here this is a flat area, but if we were not in a flat area, if we were in an area with mountains or obstacles, we would see this obstacle, you see. So in certain occasions, EVS can bring some more safety by improving the visibility. I don't know if you remember the EHEST study. Yesterday, Ellie Offshore was mentioning they were collaborating with NLR, and this study had been done for EHEST by NLR, and it was a conclusion of NLR/EHEST about the EVS. And it was 3 years ago, and I think it is, of course, still valid. So the EVS brings solution in darkness and in any condition of DVA, and as I said earlier, up to 10 times the human vision, depending of weather condition, depending mainly on the humidity, because as every infrared system, there is some degradation when the humidity is very high. ZVS is a very simple system to operate. In fact, you only have 2 switches, you see, on-off and a zoom, you see. So this is why no basic training, no recurrent training has been required, you see. So once you have done the investment, you have no recurrent cost with ZVS. We have several STCs, ZVS being an American product. We have, of course, more STCs in the FAA world, but we have some already in EASA world, of course. And this is my conclusion, you see. This is a safety system, and only a safety system. That's it.
Thank you, François. Now, if you have any doubt.
So how do you fix it?
you can ask some other questions, but EVS system is probably a very interesting system for most of our operation. Now you just have to decide if you need it or not on your aircraft. So this is a question and answer before going for lunch. So please have a start. Who is the first? No more question? So I will start with one question to you, François. I asked you a few weeks ago when you sent me the presentation, what could be the combination between the EVS system and the NV system? NV system, the global system, I mean goggles and the aircraft equipment. How can you use it and how you can manage both of them?
At MaxViz, we are of the opinion that NVGs and EVS are 100% complementary, you see. And we see no competition at all. One of my pictures was on an instrument panel on a Bell 429, you see, equipped with our EVS and flying also under NVGs. And according to the operator, it works fine. During certain nights at high altitude, when you have no houses anymore, if you have a very dark night, and I think this is valid also in the northern part of Europe, I was told, because I have never flown with NVG, so I just repeat, I was told that in certain dark nights, you see, NVG is not enough, you see. So if you had the NVG technology plus the infrared technology, you rely on two different systems, and I believe that we cover a larger spectrum by improving the visibility for the crew.
Is there anyone in the room having experience on both NVG and EVS? Do you have any experience on it?
Yes, hi, David Stubbs. Yes, in the military, I've flown various systems, forward-looking or in fact fully articulated infrared and full-color camera systems. And a blended picture, in my view, is the ideal solution because it's all circumstantial as to which device will give you the better image. And it's an aid, in my experience, not an outright solution. So sometimes the NVG image can be better than the FLIR image, but nearly always FLIR will see better than night vision goggles, particularly if you're fairly low. At high altitude, it's less of an issue. My experience.
Okay, thank you.
Yes, I'm thinking about the firefighting video that you showed. Could that system be installed in a remotely piloted aircraft and then have the monitor somebody in the ground to see the fire?
Can you repeat your question?
Can that system be installed in a drone, for example?
In drone,
Yeah.
okay. I have no personal experience, and I am sure that at MaxViz we have not sold so far any EVS to a drone operation. You see, but when we see what has been done on fixed wing, you see, or on helicopter, I assume it could be done on drone, but so far we have not delivered any EVS to drone. But we have that small sensor, the 1400. The weight is only 1.2 kg. You see, so on certain drones, I think it could be compatible on certain drones. But so far we have no experience.
Good morning, Thierry Savoy, Thales. What are the constraints for the installation of the sensor in terms of what is the best location? I saw for the helicopters the sensor were installed downwards. On the BizJet aircraft, I saw a picture was more upwards of the radar.
The best location usually is in the nose, you see, because as we must have a sort of 5 degrees look down angle, the nose seems to be the best place. You
Do
see.
you mean the nose upwards or
Downwards. Yeah.
Downwards,
Yeah.
okay.
But on the 1400, it has been designed to be that it can be possible to install it on the roof, you see. But so far, I have no knowledge of any installation on the roof on helicopters. We have done that on fixed wing, but on helicopters, so far, everything I have seen is under the nose.
And for the human factors, you take into account the parallax or try to minimize?
We put it usually on the pilot side, you see, in order to minimize the parallax.
Okay, that's it. Thank you.
Yes, let's go ahead. Other questions? No? No more questions? MPPM? No? Want? Thank you very much. So now it will be the lunch break time in a few minutes. So you still have some minutes to talk each other, to talk together. Thank you very much. And we come back for the last session in the other rooms, the plenary sessions. We expect to restart at 13:45, 1:45 p.m. Thank you very much. See you later.